Welcome to the Last Economy podcast, a guide to the age of intelligent economics.
Today, we are undertaking a really fundamental deep dive. We're opening up chapter 11 from the book titled The Cathedral and the Bazaar 2.0.
Yeah, and this one feels crucial. If you really want to understand where work is heading, how value is going to be created, well, you have to get your head around the basic architecture of the whole system.
Exactly. It's the blueprint of the economy itself.
So our mission today, for you listening, is to take this huge, sometimes kind of abstract battle, this push and pull between the market and the firm, and boil it down into insights you can actually use.
Right. This isn't just theory for academics. It digs into why some companies seem to be adapting to AI, even thriving, while others, well, they look incredibly fragile right now.
But we want to show you, really stress this point, that this isn't about, left versus right or capitalism versus something else. The book argues it's about architecture. It's computational.
Which is a different way of looking at it. And to really get the stakes, we need a little bit of history. Because the speed of change right now, it feels unique, but the kind of change, the organizational impact, we've seen echoes before.
We're watching whole job types, things we thought were safe, knowledge work, suddenly seem vulnerable.
It's a phase transition. And the book kicks off with this really powerful anecdote. It's almost a bit chilling.
Takes us back to the 1950s. NASA's Langley Research Center.
Picture this. Entire rooms, wings of buildings filled with these brilliant people, mostly women, actually, and their job title. Literally human computers.
Yeah, it sounds strange now, doesn't it? But they were performing these incredibly complex calculations, ballistics, trajectories for the space race, all done by hand or with mechanical calculators, highly skilled. Indispensable.
They were the original knowledge workers in a way, the peak of human brainpower applied to a big, organized project, a firm's execution engine.
But then came the machine, the electronic computer, specifically the IBM 7090. And this thing, it just blew them away. It could do more calculations in minutes than one person could manage in, a lifetime.
Pretty much, and the shift wasn't gradual, it was immediate. Absolute.
That job title, computer, meaning a human calculator, gone, almost overnight.
And the crucial point the book makes is why. They weren't replaced because they were bad at their jobs or lazy or unskilled. They were replaced because a different kind of processor arrived. Non-metabolic, didn't need sleep or food. Exponentially more scalable. It did their exact function, just faster and cheaper at scale.
And that's the parallel. That's the jolt for us today.
Right. We're the people sitting at screens now, managing data, analyzing things, writing code, making PowerPoints.
We're the professional descendants of those human computers at NASA.
And our IBM 7090 has arrived. It's AI. Fast, scalable, non-metabolic intelligence.
So the million-dollar question, maybe the trillion-dollar question is, if that core cognitive work that built the modern company is being automated, what kind of company survives?
And to answer that, you need to understand this deep architectural conflict, the two minds of the economy.
Okay, let's unpack this core split. For, centuries really, Western economic thinking has revolved around these two big ideas, the firm and the market.
Right. And for a long time, the big puzzle, the academic question was, why do firms even exist?
Seems obvious now, maybe, but back then.
Yeah, think about it. If the market is this supposedly perfect engine for efficiency, coordinating everything with price signals, why bother creating these hierarchies, these companies where managers just tell people what to do?
That brings us to Ronald Coase. 1937, he asked that exact question.
And his answer became famous. It dominated economics for decades, he said. Transaction costs.
The friction.
Exactly. The hassle, the cost, the time involved in constantly using the market for everything. It's just too high.
It's simpler, cheaper, faster to just order an employee inside your company to do task X
than it is to go out, find a freelancer, negotiate a contract, monitor the work, handle payment, deal with disputes. Every single time you need task X done.
The paperclip example you mentioned earlier is perfect.
Right. You need a paperclip. Are you going to log on to a global commodity exchange?
No.
Negotiate with a factory in, Vietnam. Contract shipping, deal with customs, haggle with FedEx.
Of course not. You hire an admin assistant, part of the firm, who just keeps a box of them in the supply closet. Much cheaper.
Transaction costs. They make the firm make sense.
Okay, but here's the twist the book brings in. We're now in the economy of bits, not just atoms.
Right. Digital tech, the internet, mobile payments, global platforms.
All that stuff has driven transaction costs for so many things way, way down, towards zero almost.
Communication is instant. Contracting can be templated and automated. Payments are cheap and global. Finding someone, platforms do that.
So if Coase's reason high transaction costs is disappearing, why are firms still here? Why haven't we all just become like hyper-efficient solo freelancers coordinating everything through the market?
That's why the book argues we need a deeper explanation than just friction. It's not just about transaction costs anymore.
It's about information.
Exactly. The firm and the market are fundamentally different architectures for processing information. Choosing between them isn't just about cost saving, it's about choosing a type of computational system. They do different things well.
This is where that central metaphor comes in. The cathedral and the bazaar. It gives us that architectural clarity. Let me read, quote, #1 directly because the phrasing is really specific. Host speaker, reading, quote, #1. The firm is a cathedral built according to a deliberate blueprint. The market is a bazaar, chaotic and vibrant, where order arises from the bottom up.
Yeah, it's a great image. And the key is, it's describing their function, their structure, not judging them morally.
The cathedral, the firm, it's planned, rigid, follows a blueprint, top-down control, information flows through set channels.
It's serial processing in computational terms, designed to execute a known plan, a single idea, with maximum efficiency and minimum deviation.
And the bazaar, the market, totally different vibe.
Totally. It's messy, noisy, decentralized, thousands of conversations, transactions, experiments happening all at once, bottom up, emergent order, if any.
Think of it, the book suggests, as a massively parallel computer.
That's the core idea. Its strength isn't execution of a known plan. Its strength is discovery.
Finding the new things.
Yes. Exploring a huge space of possibilities, millions of agents trying slightly different things, constantly getting feedback through price signals, succeeding, failing, adapting. It's chaotic, but it's incredibly powerful at finding new ideas, new niches, optimizing for the unknown. It minimizes prediction error by basically trying everything.
Okay, so the market discovers, finds that new opportunity, that surprising connection.
And then the firm, the cathedral, often steps in.
To execute.
Precisely. The firm is the serial hierarchical system built for execution. Once the market somehow validates an idea, hey, people actually want electric scooters, the firm can take that single validated concept and exploit it, scale it up, refine it, optimize it ruthlessly.
And inside the firm, resources don't flow because of fluctuating market prices.
No, they flow because a manager decides. Command and control. The hierarchy reduces complexity for that specific task. It minimizes the cost of coordinating the execution of that one plan. It's built for refinement and scaling something already discovered.
So the bottom line of this section is really powerful. The big economic fight we're seeing, especially with AI accelerating everything, isn't ideology. It's a computational contest.
It's about which architecture, the cathedral's focused execution or the bazaar's distributed discovery, is better suited for processing the insane amount of information flooding the system in the age of bits and AI, or maybe how to combine them.
Okay, so if we're navigating this computational battle, you'd think we could rely on the classic economic models, right? Stuff taught in MBA programs for decades.
You would think so. But the book makes a pretty strong case that many of the most elegant, mathematically beautiful theories of the 20th century, they actually failed us. They didn't predict the kind of instability we're seeing now.
Why not? What was missing?
They assumed an impossible world. They were often obsessed with proving how things would work out perfectly if the world had no friction.
A frictionless world. Sounds nice.
Yeah, a world where information flows instantly and freely, negotiation costs nothing, contracts are perfect, everyone is rational, all these simplifying assumptions. The book calls it assuming a flat, simple economic manifold, like a perfect geometric plane.
But reality isn't flat.
Not even close. It's curved, complex, messy, full of friction and information gaps, and frankly, irrationality. So these beautiful theories, while logically sound within their own assumptions, were built on foundations that didn't exist in the real world. They became useless or even dangerous for navigating the actual landscape.
Can we dig into those examples you mentioned, Coase again and Modigliani Miller? Because they really show the danger of assuming that flat world.
Absolutely. Let's take Coase again. His theorem said, basically, that if transaction costs were zero, it wouldn't matter who initially owned a property right, say, the right to pollute or the right to clean air.
Through negotiation, the resource would always end up being used in the most economically efficient way, regardless of who started with the right.
Exactly. Remember the factory and the farm. If the factory profits $100 from polluting and the farmer loses $50 in crop damage, Coase said they'd negotiate.
If the factory has the right to pollute, The farmer might offer, say, $51 not to pollute, but the factory would refuse because $100 is more. So pollution happens. Efficient.
Right. And if the farmer had the right to clean air, the factory would offer the farmer, say, $51 to allow pollution. The farmer accepts because $51 is more than the $50 loss. Pollution happens again. Same efficient outcome.
Okay, that's the elegant theory, but...
It assumes the negotiation is free, instant, and they both know exactly what the other's costs and profits are. Perfect information. Zero friction.
Which is never true. What if the farmer doesn't know the factory makes $100? What if hiring a lawyer to negotiate costs $60? What if the factory just refuses to talk?
Then the initial assignment of the property right matters hugely. It determines the outcome. That cost, that information gap, that friction, that's the curvature of the real economic world. The flat world theory breaks down.
And the same thing happened with Modigliani Miller.
Same basic problem. They won a Nobel for showing that in a perfect market, a company's value is independent of how it's financed, its mix of debt and equity.
Yeah, I remember this. The capital structure irrelevance idea.
Yeah.
The total value of the pie is the same no matter how you slice it between debt holders and equity holders.
But look at the assumptions they needed for that perfect market. Zero taxes, zero bankruptcy costs, perfect information, everyone rational. Lenders and borrowers have the same info.
Which is pure fantasy.
Completely. In reality, taxes heavily favor debt. Interest is deductible. Bankruptcy is incredibly costly and messy. Information is never perfect. Insiders know more. These frictions, these imperfections, totally change the game. Capital structure becomes one of the most critical strategic decisions a firm makes. It's not irrelevant at all.
So the takeaway is, because the world isn't flat, these decisions like assigning property rights or choosing debt versus equity aren't just administrative details.
No, the book calls this topology engineering.
Topology engineering. Explain that.
It means you're actively shaping the underlying structure, the geometry of the economic situation. You're creating constraints, pathways, flexibilities. It's like designing the landscape the business has to navigate.
Okay, let's use that debt versus equity analogy again to really make this concrete. How does that relate to geometric constraints?
Think about debt. Taking on debt, especially significant debt, forces the company into a certain shape. It creates geometric rigidity.
Rigidity, how so?
Because debt demands fixed, regular payments, interest, principal. Regardless of whether you had a great quarter or a terrible one, that forces the company onto a very specific path. High velocity, maybe, but very little room to deviate.
Okay, I see. It disciplines the organization, focuses everyone on hitting those numbers to make the payments. Good for execution, maybe.
Excellent for execution, potentially. If the path is clear and the environment is stable, that rigidity can drive efficiency. But it makes the firm incredibly brittle.
Brittle because if something unexpected happens, a recession, a new competitor, a technology shift like AI.
Exactly. That fixed path suddenly leads off a cliff. The firm can't easily pivot, can't absorb the shock because it's locked into those debt obligations. The rigidity that helped it execute now ensures its destruction. A prediction error becomes fatal.
Whereas equity.
Equity is different. Equity provides geometric flexibility. Equity holders don't get fixed payments. They get a share of the residual profit, if any. They demand long-term viability, adaptability, optionality.
So it acts like a buffer.
A ballast. Precisely. It allows the firm to absorb shocks, to change direction, to invest in uncertain long-term projects, to survive downturns. It provides the strategic flexibility needed to navigate a volatile, unpredictable, curved economic world.
Wow. So choosing your capital structure isn't just finance. It's literally deciding how resilient, how adaptable your organization's geometry will be.
It's a negotiation with reality's inherent uncertainty and complexity. And in an age defined by accelerating change and AI disruption, choosing rigidity, well, it looks increasingly like choosing a very efficient path to extinction.
Which ties perfectly into the next big idea, the innovator's dilemma, how that efficiency itself becomes the trap. Okay, we've established the firm, the cathedral, is this amazing engine for execution. But you're saying that very strength, that focus, becomes its Achilles heel.
It's the core tension, isn't it? The book paints it as this necessary, almost tragic dance. A healthy economy needs both sides.
The market discovers, the firm executes.
But if the firm executes too well, becomes too optimized for its current success, it loses the ability to see or act on the next discovery.
Let's hit quote #2 here because it captures that balance perfectly. Host speaker, reading quote #2. The market is an engine for discovery. The firm is an engine for execution. A healthy economy needs both.
The significance there is that success isn't just luck. It creates structure. It builds an internal algorithm.
An algorithm, you mean like computer code?
Sort of. Think of the algorithm as the sum total of how the company works. Its budget processes, its reporting lines, who gets promoted, what metrics are rewarded, the corporate culture, the unspoken rules.
All the systems and habits.
Yes. And when a company is successful for a long time, that entire algorithm becomes perfectly tuned, perfectly optimized for solving one specific problem in one specific market environment.
Okay, makes sense. You get really good at what made you successful.
But what happens when the environment changes, when a new technology emerges?
Mm-hmm.
Or customer tastes shift? That perfectly optimized algorithm, the one that guaranteed past success, now guarantees failure. It literally can't process the new reality.
The book uses this fantastic analogy from AI to describe this. It calls it overfitting.
Yeah, overfitting is a huge problem in machine learning. You train a model on historical data, the training set.
Right.
If you train it too perfectly on that past data, it doesn't just learn the underlying patterns, it starts memorizing the noise, the specific quirks, the irrelevant details of that particular data set.
So it gets like 100% on the test using the old questions.
Exactly. It aces the past. But because it memorized noise, instead of learning the general principles, when you show it new data from the future that looks even slightly different, it completely falls apart. It can't generalize. It's become brittle.
And successful firms do this structurally.
That's the argument. They overfit their entire organization, their processes, their culture, their incentives to the specific conditions that created their past success. They become computationally fragile precisely because of their specialization.
So when we see a giant, dominant company get completely disrupted by a tiny startup, it's not always because the CEO was asleep at the wheel or people were just arrogant.
Sometimes, sure. But often, the book argues, it's a deeper computational problem. The organization's very structure, optimized for the old reality, literally cannot process the disruptive innovation. It sees it as noise, as an error, as a distraction from the profitable core business.
The system is built to reject it.
Built to minimize deviation from the known successful path.
Which brings us to the classic painful example. Xerox PIARS.
Oh, Xerox PIARS.
Yeah.
It's the archetype, isn't it? The ultimate story of the execution engine destroying its own future.
Set the scene. Palo Alto Research Center, 1970s. This place was like Edison's lab meets Bell Labs on steroids.
They basically invented the entire modern computing paradigm, the personal computer as we know it, the graphical user interface, windows, icons, menus, the mouse, the laser printer, Ethernet networking.
They had the keys to the kingdom, the digital kingdom.
They really did. The blueprint for the next 30, 40 years of technology.
And yet, Xerox, the giant parent corporation,
fumbled it completely. Let competitors, famously Steve Jobs and Apple, just walk in, see the demos, and essentially walk out with the future for free.
It seems unbelievable in hindsight. Why? How could they miss something so huge?
Again, the book argues. Architecture. Not stupidity, not lack of awareness. Architecture. The Xerox Corporation of the 1970s was a perfect cathedral. A ruthlessly efficient execution engine optimized for one thing: leasing massive, expensive, high-margin analog photocopiers.
And selling the toner, the consumables,
Yeah.
that recurring revenue model.
Exactly. That was their algorithm.
Yeah.
Highly profitable, deeply ingrained, perfected over decades. Everything in the company, sales, service, finance, manufacturing, was built around that model.
And the personal computer, the stuff PRC invented.
It didn't fit the algorithm at all.
How so?
Well, think about it. A PC was relatively small and cheap. It was meant to be sold outright, not leased for huge sums. It didn't use toner. It didn't need a centralized, highly trained Xerox technician service network.
It broke the model.
Computationally, it was indigestible. It was a massive prediction error, according to the successful copier algorithm. Anything that didn't fit the lease-heavy, consumables-driven, centralized service model. The execution engine was programmed, structurally, to ignore it or reject it.
Wow. So their perfection in the old market made them blind and incapable of acting on the new one.
Their successful algorithm overfit the past so badly that it executed itself right out of the computing revolution. The future was happening in their own labs, and the corporate structure literally couldn't process it.
That's terrifying.
Yeah.
It means the way you organize today, the way you reward success, isn't just about this quarter's results.
It's computationally programming your ability or inability to survive the next disruption. You might be building the most efficient engine for driving straight towards a cliff.
Okay, let's take this idea of the rigid, overfit cathedral structure and connect it back to the AI inversion we talked about at the start.
Right. If AI, this fast, non-metabolic intelligence, is starting to replace the core cognitive work done by humans, what happens to the organizations designed entirely around managing those humans?
That traditional pyramid structure.
That entire way of organizing becomes, the book argues, an evolutionary dead end. And this leads to maybe the most provocative quote in the chapter. Let me read, quote, #3, expert speaker, reading, quote, #3. The traditional firm, a hierarchical pyramid of human components, is an evolutionary dead end. This is the slow AI we have been building for centuries.
A slow AI.
Wow.
That reframes the entire history of management and corporations.
Doesn't it? It's a stark perspective, but it makes a certain kind of sense. Think about what the traditional hierarchical firm did.
It organized people, managed tasks, set goals, controlled information flow.
Yes, but why that specific pyramid structure? The book argues it was a system designed for social domestication.
Domestication, like training animals.
In a way, it was engineered over centuries, really, to produce standardized, predictable, compliant human components cogs for the industrial and then the corporate machine.
How?
Think about the factory school system that emerged alongside industrialization. What did it teach? Sit still for hours, respond to bells, follow instructions precisely, work quietly in assigned batches, defer to authority.
Training for the factory floor or the office cubicle.
Exactly. Then layer on the corporate structures. Rigid hierarchies, silo departments, annual budget cycles, standardized performance reviews. It was all part of the software for this slow AI. It optimized for control, predictability, scale, standardization of the human element.
And creativity, discovery, adaptability.
Often, those were bugs in the system, not features. They introduced variance, unpredictability. The hierarchy was necessary precisely because human processing units, our brains, are relatively slow, expensive, inconsistent, and need a lot of management overhead to function predictably at scale within that rigid structure.
So the pyramid wasn't just about efficiency. It was about managing the limitations of biological intelligence.
That's the core argument. And now comes fast, cheap, scalable, non-metabolic AI labor. It can perform many of those cognitive tasks without the need for the elaborate, costly, friction-filled social structure built to manage the slow human AI.
So why keep the expensive management structure when the components it was designed to manage are being replaced or augmented by something fundamentally different?
Exactly. The rationale for that deep, rigid hierarchy starts to evaporate. The book uses the dinosaur analogy here.
Big, powerful, dominant.
But ultimately running on a tiny centralized brain, C-suite maybe, with massive metabolic overhead. All those layers of management, the buildings, the support staff, vulnerable to sudden environmental shifts.
Okay, so if the traditional corporation, the cathedral, is the dinosaur facing an extinction event, what comes next? What are the mammals in this analogy?
The book points towards the community, and not community in a vague feel-good sense, but as a specific organizational architecture.
An architecture that does what?
It deliberately blurs the line between the firm cathedral and the market, Bazaar. It tries to create a symbiotic intelligence.
Symbiotic how?
By finding ways to combine the execution focus, the discipline, the persistence of a core firm-like structure, with the distributed parallel discovery power, the innovation engine of a decentralized market-like network.
They realize they can't just build walls anymore.
Yeah.
They have to let the chaos of the market in, somehow harness it rather than shut it out.
Yes, because in a fast-changing, complex world, that discovery engine is too valuable to ignore. You need continuous adaptation. So the new models are often modular, distributed, hybrid.
The book gives concrete examples, right? These aren't just theories.
Exactly. Look at Linux.
The open source operating system was a huge chunk of the internet, servers, Android phones.
Right. How is it built? It's not a traditional corporation.
Yeah.
But it's not pure chaos either.
It's a hybrid.
Perfectly put.
Yeah.
It has a core group of maintainers, led historically by Linus Torvalds. They function like the firm's execution engine discipline, hierarchical in decision-making about the core kernel, ensuring stability, quality control, managing releases. That's the cathedral part.
But the vast majority of the work, the new features, the bug fixes, the drivers for new hardware, the sheer innovation,
Comes from a massive global, sometimes chaotic network of volunteer developers, thousands of them, operating like a distributed bazaar, testing ideas, submitting patches, arguing on mailing lists. The discovery happens in that network.
and the coherence The stable operating system emerges from that managed chaos.
It's a brilliant symbiotic structure, execution and discovery woven together.
Wikipedia is another example the book uses.
Another perfect one. You have the Wikimedia Foundation. That's the firm element. They handle the money, the servers, the legal stuff, the core infrastructure. They provide persistence and stability.
But the content, the millions of articles, the edits, the translations, the arguments on talk pages.
That's the Bazaar. Millions of distributed, often anonymous editors constantly creating, correcting, updating. It's messy, it's imperfect, but it has produced the largest encyclopedia in human history, something no traditional top-down corporation could have ever achieved.
So these successful community models show it's possible to build organizations that are both focused and adaptable.
They demonstrate that maybe the goal isn't just one or the other, Cathedral or Bazaar, but finding intelligent ways to integrate both information processing architectures.
Which leads to that final metaphor you mentioned about intelligence itself.
Yeah.
The old way tried to build this single, unified corporate mind, the cathedral.
Yeah, this idea of the all-knowing CEO or the perfectly rational strategic plan. But what we're learning, both from neuroscience looking at the human brain,
Which is incredibly parallel and often chaotic.
and from these successful new organizational models like Linux or Wikipedia, is that real robust intelligence isn't usually a single monolithic consciousness.
It's more like an emergent property.
Exactly. It often arises from a messy, parallel, distributed process of discovery, a bazaar of competing ideas and signals from which fragile, temporary, localized coherence or execution emerges when needed. The challenge isn't to eliminate the chaos, it's to build structures that can harness it. Hashtag outro.
Wow. Okay, that was a really deep dive into the fundamental architecture, the computational core of the economy that's emerging.
Yeah, we've seen how this tension, this conflict between the rigid firm, the cathedral, and the flexible market, the bazaar, isn't just academic. It's playing out right now, determining who survives the AI shockwave.
The implications, like you said, for everyone, knowledge workers, managers, leaders, are huge. The way we've always organized work, it might just be fundamentally obsolete.
The assumptions are breaking down.
So let's try and nail down the main argument of this whole chapter. If we had to put it in one sentence.
I'd say it's this. The greatest challenge facing the intelligent economy is designing hybrid institutions that combine the firm's power of execution with the market's power of discovery.
Finding that symbiotic balance. Okay, and the key takeaways for everyone listening, let's list them out.
Okay, first, remember the core architectures. The Fahm Cathedral is serial, hierarchical, optimized for execution. The market, Bazaar, is parallel, chaotic, optimized for discovery. Fundamentally different information processors.
Second, those elegant old economic theories. Coase, Modigliani Miller. They often failed because they assumed a flat, frictionless world. Reality is curved and complex. Decisions about things like debt versus equity aren't just financial. They're topology engineering shaping your resilience.
Third takeaway. The innovator's dilemma is basically computational overfitting. Getting too good, too specialized at yesterday's game makes your organization brittle and unable to process tomorrow's reality. Think Xerox PAR.
And finally, the traditional hierarchical corporation built around managing slow human cognitive labor. The book frames it as a slow AI, an evolutionary dead end in the age of fast AI. The future likely belongs to more flexible, symbiotic communities like Linux or Wikipedia that blend execution and discovery.
Those are the core pillars, I think.
Right. But just recognizing this architectural conflict, this dance between the cathedral and the bazaar, that's really just step one. Isn't it?
Absolutely. If they're playing this high-stakes game, this constant dance of transformation, what are the actual rules of engagement? How should they interact?
Which leads us perfectly into the next chapter.
Exactly. Because for decades, we've tried to understand strategic interaction using game theory developed in the 20th century. Models like the famous prisoner's dilemma.
Which usually concludes that betrayal or defection is the rational choice.
Right, often leading to pretty pessimistic, zero-sum conclusions. But what if the physics of information, the very nature of this new economic environment, changes the game itself?
So next time we're diving into Chapter 12, Intelligent Game Theory.
We'll explore how this new landscape might actually favor a different outcome, a higher equilibrium the book calls the symbiotic equilibrium. And we'll see why, in the age of intelligence, cooperation might not just be a nice idea or a moral choice. It might be the mathematically optimal strategy for survival.
Fascinating. Okay, don't miss that one. Join us next time for Intelligent Game Theory. Thanks for diving deep with us today.